Hey, Algebra 1, Mr. Schachter back at you with an exponential example. Let's take a look at this example that deals with insect population. Gross. All right, first things first, let's take a look at the x. The x is going to be the time in days, and the y is going to be the population. Now, a couple of big things you have to understand about an exponential. First of all, in order to be exponential, as you move down the y column, you need to be multiplying by a number. No longer are we adding, okay? In this example, that multiplier is right here. That multiplier is times 3. So each time we move down, we're timesing by 3. So if we were to take a look at the exponential formula, ab to the x, what we know is that the multiplier is 3, all right? We also can calculate the initial value. Now, the initial value is the y value when x is equal to 0. In this problem, when x is 0, y is 2. 2 is the value of a. Remember that the value of a is also the initial value of whatever the problem is talking about. In this example, we're talking about the insect population. So the a would be the initial number of insects. So when the time is 0 days, we begin with 2 insects in our population. All right? And then the x always remains x, okay? It's the independent variable in our problem, meaning that we can plug whatever we want in and solve for the dependent variable y. In this problem, x represents time in days, okay? Over here to the right, you're going to see the points plotted on a coordinate plane. And if you were to connect the points, you're going to see that they kind of start off increasing, but then as they go, they increase faster and faster and faster. And that's the whole exponential aspect to this, okay? So we've got this little curve here. And if I kind of extended it in the other direction, like this, you'll see it kind of looks like the capital letter J. If I put like a little top on that letter, it looks like the capital letter J. And that's why in science, I'm sure you guys have referred to that as the J curve. And exponential functions take the shape of that J curve, okay? This particular function seems to be growing as the days go up. So as time goes up, the population is growing. And conversely, if we have a curve that looks a little bit different, like for example, we could take a look at a curve that does the opposite. As time goes on, the curve kind of shrinks and gets closer and closer to 0. And this is going to be exponential decay. We'll take a look at these a little closer in future videos.